Hello everyone. Today we will talk about C++ object types and conversion. C++ object types. C++ has a large number of fundamental or built-in object types. The fundamental object types fall into one of the three categories: integer objects, floating point objects, character objects. Integer object type. The basic integer object type is int, represented as int. The size of an int depends on the machine or the compiler. On PCs, it is normally 16 or 32 bits. Other integer object types, short, typically use less bits, often 2 bytes. Long, typically use more bits, often 4 bytes. Different types allow programmers to use resources more efficiently. So programmers have to make wise decisions that they have to select an appropriate object type to write a program. They don't have to waste their resources. Standard arithmetic and relational operations are available for these types. So you can perform all the standard arithmetic and relation operations on the operators of these different object types. Integer constants. An integer constant is the value that is determined at the compile time and cannot be changed at the runtime. So its name indicates that it is the constant, the integer constant. Variables, as you know, that their values can be changed, but the constants, its value indicates that it can't be changed. Integer constants are positive or negative whole numbers. Integer constant forms. One of the form is the decimal, having the base 10. The numbers ranging from 0 to 9. The examples include 255, 150, and many more other examples are there. The second one is octal, having the base 8, with the numbers ranging from 0 to 7. The examples, one of them is 046, 0377. You can notice that this decimal numbers doesn't have any zero number, but in octal you can notice that you have the numbers are starting from 0. Hexadecimal, having the base 16. Here you can notice that these type of numbers are starting from 0x. Here numbers are ranging from 0 to f. The numbers that is from 0 up to 9, and then a up to f. The total number of 16 numbers we have. This is the program indicating the integer constants. Look at this statement. Here we have written that, here we have declared an integer, which is not a simple integer, but a constant integer. And we recognize that this is a constant by looking at the keyword const. This is a keyword which is specifically for the constant. And we have specified that this is a constant integer, x, and we are assigning 15 to this constant integer. Now, its value can be changed. Here, int y equal to 015, which is an octal integer, and we can change its value later on. Character object type. char is for specifying character data. Character variable may hold only a single lowercase letter, a single uppercase letter, a single digit, or a single special character like $7, static, etc. These are case sensitive. Small a is not the same as the capital A. ASCII, American Standard Code for Information Interchange, is the most common character encoded format for text data in computers and on the internet. ASCII is the dominant encoding scheme, having unique values for 128 alphabetic, numeric, or special additional characters and control codes. So it means that you have some ASCII codes for all of these 128 alphabetic, numeric, and special additional characters and control codes. For example, space has the ASCII code of 32. Capital A have an ASCII code of 65. Small a has the next ASCII code of 97. Similarly, for plus, it's 43. Capital Z, it's 90. Small z, it's 122. Explicit literal characters within single quote. So you have to specify the characters within these single quotes. Look at this example. Small a has been placed within these single quotes, specifying that this is a character. So whenever you are going to assign character a to its variable, then you cannot simply write here a, but you have to specify it within a single quote. There are special characters too, but they are delineated by backslash. Two character sequences. These are two character sequences, escape codes. This is an example of escape codes, special escape codes, \t. If you write here \t in your program, it is denoting tab. \n is for new line, and backslash will print backslash on the console. \single quote is used to print single quote on the console. \double quote denotes the double quote. Floating point objects. Floating point object types represent real numbers. It consists of integer part and the fractional part. The number like 108.1517 can be broken into the following parts. 108, this is the integer part, and 1517 is the fractional part. C++ provides three floating point object types. Float, often 4 bytes, declares floating point numbers up to 7 significant digits. Double, often 8 bytes, declare double point numbers up to 15 digits number. Long double, often 10 bytes, declare floating point numbers up to 19 significant digits. Now we will talk about type compatibilities. If you store values of one type in variable of another type, the results can be inconsistent. So it's not necessary that if you are going to assign or store a value of one type of variable to the other variable, which is having a different data type, the results, it's not necessary that the results are the same that you are expecting. It can store integers in floating point, can store integers in the floating point, or in characters assumed as fixed value. So there is a possibility that you are going to store integers in the floating point, and you can assign you can assign integers to the characters, right? So floating point actually reserves more memory, they have more capacity, and integer have some less memory. So integers can be stored in the floating point. But in case of characters, if you are going to assign integer, it will assume that some ASCII code have been assigned to the character. As you can see that every character have an ASCII code, which is an integer type. So it will assume implicitly that some ASCII code is assigned to it. Boolean can be stored as in. Boolean has two types, like it can having a true or a false. So for true, it can be a non-zero, and for false, it can be 0. So 0 or non-zero as an int can be assigned to the Boolean. So this is the implicit promotion in which integers are promoted to doubles. Here you can see that double variable equal to 2, which means that the result will be 2.0. So you can see that the value we are going to assign to the variable, which is of data type double, what is going to happen that though the variable, the value which we are going to assign is of type int, but as we are promoting it up to the higher level of data type, which is double, so in double, the values are usually represented as the as of this form, like 2.0. So it will be implicitly promoted from 2 to 2.0 on integer and double together. So what will happen when we have an expressions in which we have both integers and doubles? This will be called as mixed type expressions, in which one of them is integer and the other is a floating. So if both the operands are int, the result will be an int. Otherwise, if one of them is float, the result will also be in float. The compiler tries to be value preserving. General rule, promote up to the first type that contains the value of the expression. Note that representation doesn't change, but the value can be altered. Promotes to the smallest type that can hold both values. This can be clear from this example. If assign float to int, if we are going to assign float to int, what will happen? In the previous example, we have seen that we are going to assign into the into the float. So float has more capacity, so int can be adjusted in this case. But here, value which is already in the bigger capacity, it's going to enter some space which have low capacity. So there will be some this can't be adjusted. Something will be truncated out of that. So in this case, you can see that 2.99, you can see by this value that it's a floating point number, and we are going to assign it to some integer variable. Then what will happen? Then the result the result will be integer, right? As the variable that we are going to assign is an integer value. It doesn't have any capacity to store a value of floating point. Obviously, 0.99 would be truncated and 2 will be preserved there. If we assign int to float, will promote to double. So if we are going to assign 2, which is an integer, to the variable which is of double, then it will automatically be promoted to 2.0. This was all about implicit conversion. Now, what will happen if we explicitly or force the data types to be converted? So here we'll talk about explicit conversions. So here we have the casting, which is called casting, forcing conversions by putting type in form of the variables or expressions used to ensure that the results of the desired type. Example, if you want to divide 2 integers and get a real result, you must cast 1 to double so that the real divide occurs. Store the results in a double. So for example, you have 2 integers and you are going to divide it. What you would be expecting? Though we have 2 integers and we might have some such values in those integers that their divisions result in a floating point number. But when we display this integer divisions, we might not get the results that we are expecting. Just like in this example, you can see that we have x equal to 5 and y equal to 2. Both are integers. So when we are going to divide both numbers, the result will be 2.5. But if we only do print their divisions, the result of their divisions, we will be surprised and we will get only two value. So how can we avoid this situation? We have to convert one of the operand to double so that we can get the real result at the end. So here we have the 2 x and y, both are the integer, having x value 5 and y equal to 2, and double z. This is a declaration to store the result of the division. So z equal to static underscore cost double. And here we are going to explicitly casting x operand or x variable to the double and then dividing it by y. By writing this statement, we can get the desired result, which is 2.5. In the next example, we are again going to explicitly casting x to double and then dividing by y, getting the same desired result. In the third example, you can see that here we have, first of all, we are doing this integer division. So at the result of integer division, we will get the result 2. Now 2 is going to explicitly cast into double. So ultimately the result will be 2.0. Converts x to double and then does mixed division, not integer division. Static cast int z will truncate z. So if you are going to cast the result which is in the floating point or in or double, having the double data type, and then you are explicitly casting it to the integer, what will happen? In the fractional part will be truncated in this case. In this example, x plus 0.5, x is representing integer, and then we are adding its fractional part to it, and then the whole result is again casting into integer. So what will happen in this case? It will round positive x to cast, and we are using this round bracket or parenthesis to cast the complete expression. So it's not just x, but x plus 0.5 and within this parenthesis. So the result will be cast into the integer. Cast division of integer to give real results. X equal to 5, y equal to 2, both integers. We have the double z to store the result. Z equal to static cost. We have double and then x by y. So we have the result will be 2.0. If we want to get the real result, we have to convert one of the operand into the double.